As part of my problem series in this video, I will be calculating current using the superposition theorem. Once I am finished with this series, I will be posting them in my StanStore at this web address. Before proceeding, I want to explain the three web addresses that you will be directed to using. You have already seen the first here. This is a web address of my StanStore, which will give you direct access to all of my electrical courses. On the last page, you'll find an address that will direct you to obtaining the 50-page crib sheet and notes that will not only be handy when you're taking my courses in my StanStore, but also for reference during any time during your career. Here you'll also be asked for your email address, which will not be shared with anybody or distributed in any way, but it will allow me to keep in touch with you and let you know of any additions or updates to my courses and or blogs. Near the end of the video, I'll be introducing you to a supplier of electrical products, which in my estimation are of value worth paying attention to. In this problem, we are to calculate the value of the current through resistor R3 in this DC network using the superposition theorem. The superposition theorem states in any linear network containing more than one source of electromotive force or current, the current through any branch is the algebraic sum of the currents produced by each source acting independently. Because the voltage source EB has no internal resistance, the source EB is replaced by a short circuit. The total resistance seen at EA, we will call it RTA, is equal to 100 plus 100 in parallel with 100, and written out or expanded looks like this, and it's equal to 150 ohms. The total current flowing out of EA, according to Ohm's law, is ITA, and it is equal to 30 over 150, or equal to 200 milliamps. From the current divider rule, I3A is equal to 200 milliamps divided by 2, or 100 milliamps, and I2A is also equal to 200 milliamps divided by 2, equal to 100 milliamps. Returning to our original circuit, let's look at the contribution from voltage source EB. Because EA has no internal resistance, the EA source is replaced by a short circuit. As you can see, the circuit is symmetrical, so the resistance that the B power supply sees, we will call it RTB. The total resistance at EB is also equal to 100 plus the quantity 100 in parallel with 100, which is equal to 150 ohms. Therefore, ITB is equal to EB all over RTB, which is equal to 15 over 150, or 100 milliamps. Keep in mind that the B power supply polarity is the opposite to that of the A power supply. Therefore, the current will be flowing out in this direction. From the current divider rule, I2B and I3B is equal to 100 milliamps divided by 2, or 50 milliamps each. The algebraic sum of the component currents, I3A and I3B, is used to obtain the true magnitude and direction of the current through R3. That is, IR3 is equal to I3A minus I3B, which is equal to 100 minus 50, or 50 milliamps, in the direction of I3A. The superposition theorem simplifies the analysis of a linear network having more than one source of EMF. This theorem may also be applied to any network containing DC or AC sources of EMF. I want to introduce you to another product that's out there that is worthy of paying attention to, the 𝐃𝐈𝐒𝐂𝐋𝐀 F2000 generator. To find out more about this battery generator and to keep up to date on any sales or discounts that are available, simply go to the Anchor site at this web address. And by using this web address, you can get $800 off the original price, or just browse through the various options on this site. There is no charge for just looking, but you might find something that is available at a discounted price at this particular time. And remember, this video has been brought to you by PSPT, where you will find electrical training videos when you go to this web address, which will also give you a free copy of my 50-page crib sheets that you can use while viewing any of my courses, or just keep it handy during your everyday work.